This is the homework helper for Chapter 10, Section 5 in the 8th grade textbook, Making Decisions and Predictions. All right, let's go ahead and take a look at the first three questions here. Now, as you can see, these three questions all rely on the same prompt and table. It says a sports store sells water bottles in different colors. The table shows the color of the last 200 water bottles sold. The manager plans to order 1,800 new water bottles. And we're going to look specifically at question number 1, which says how many red water bottles should the manager order? Well, looking at the table, we see of those last 200 orders, 30 of them have been red. So the probability of selling a red is 30 out of 200. And we can change that to whatever form we might like to. But what the question is really asking me to do now is to bubble that up to represent 1,800 total orders and figure out then how many reds should I order. So if I'm going to bubble this up to be 1,800 total orders, I'm going to write another ratio compared to 1,800. And since I'm supposed to figure out how many red water bottles there are, that's where I'm going to put X. Now notice my ratios represent the same part to whole relationship. This is the number of red water bottles. This is the total number of water bottles. This is how many red water bottles I'm going to order. Well, remember, what was this over here? The number of red water bottles. This is the total number of water bottles. Well, what was this? The total number of water bottles based on the table. So the ratios are set up the same way. Reds on top, totals on the bottom. And all we have to do is figure out now how many reds we're going to order when we order 1,800 total water bottles. Well, you can solve the proportion any way you want. But looking at the bottom here, I'm saying, well, I'm going from 200 to 1,800, which means I'm multiplying by 9. So the same multiplier is going to have to work in the top. 30 times 9 is 270, so that means the manager should order 270 red water bottles. Now, when you're working at 2 and 3, some things aren't going to change. Right? In 2 and 3, what's not going to change are the bottoms here or this top that's going to be X. Now, its actual value when you find it will be different, but every time we write the proportion, it's going to say X. What's going to change is this figure here. You're going to change this out to match whatever scenario they describe, because remember, a winning scenario here is how we compare probabilities, and the winning scenario there is going to change in 2 and 3 to green and clear. All right, let's go ahead and take a look at some of the questions down here towards the bottom. Number 4 says, if the carnival spinner lands on the 10, the player gets a large stuffed animal. Suppose the spinner is spun 30 times. Predict how many large stuffed animals will be given away. Well, a winning scenario here is landing on 10, so there's one winning scenario. And as we can see by counting up the number of sectors, there's 6 total scenarios. So you've got a 1 out of 6 chance of landing on a 10 and winning the animal. They want us to now inflate that to represent 30 total spins. So I'm going to take this fraction and inflate it to represent something compared to 30. All right, well, realize what I've written here. Again, just like we saw a minute ago, this is the number of winning scenarios compared to the total number of possibilities, 1 out of 6, just looking at this. This new fraction, this new ratio here that's compared to 30, well, that's 30 total spins. Well, over here, that was the total. What I don't know is this guy up here. All right, that's going to be how many times it's actually going to happen. Over there, we said it was 1 time. Well, if we look at the denominators, we're going from 6 to 30, which would imply that we're multiplying by 5. The same multiplier is then going to have to work on the top. When I take 1 and multiply it by 5, the result is 5. All right, let's go ahead and take a look at 5, 6, and 7 now. 5, 6, and 7 are asking you to determine whether the game is fair. Hopefully you remember from the notes today, when you're trying to figure out if something is fair, what you're having to do is to try and figure out if the probabilities work out to be the same. If the probabilities work out to be the same in both scenarios, something is fair. If they work out to be different, something is not fair. So let's look at number 5. It says we roll 2 fair number cubes labeled 1 through 6. A wins if both numbers are the same. B wins if both numbers are different. So we can make a quick little branching diagram to show this here. We can spin a 1, or rather roll a 1, a 2, a 3, a 4, a 5, or a 6. And then on the second roll, I can then roll a 1, a 2, a 3, a 4, a 5, or a 6, which I will need to list underneath each one of these. Now, A wins when both numbers happen to be the same. So that means A is going to win when we have 1, 1, or 2, 2, or 3, 3, or 4, 4, or 5, 5, or 6, 6. So A can win 6 different times. And as we can see, when we look at totals here, counting out the bottom level of the tree diagram, 36 total possibilities. B wins when the numbers are different. Well, that's everything else that's left. So B wins the other 30 times out of the 36 total possibilities. Well, since those two probabilities there are different, the answer here is going to be no. The game is not fair. You can use that same setup, this branching diagram, to help you with number 6, because the initial part is the same here, where it says roll 2 fair number cubes labeled 1 through 6. What's different is the scenario. Then you have to add the numbers and then figure out the different probabilities. But this setup will help you get started with question number 6.